All right, so we have one participant, Petro, and Petro is currently doing MSc Bioinformatics and is interested in RNA-seq analysis. So do you have prior knowledge of R coding? All right, so let's start with today's webinar. So hello everyone, a very warm greeting to one and all. My name is Srigauri Krishnakumar and I would like to welcome you all for today's webinar on biomedical data science in our program. The biomedical data science in our program is designed for students and researchers from diverse range of backgrounds to cover practical and conceptual aspects of data science, including data wrangling, statistical analysis, and machine learning in application to high-throughput biomedical omics data. More about the program details will be covered in a couple of minutes. The aim of today's webinar is just to introduce the participants to program details such as program mentor, program curriculum overview, intended outcomes, and program registrations. I'm also excited to announce that today we will also be joined by Dr. Jeet Sarkar, Senior Bioinformatics Scientist at Elucidata, who will be speaking about prospective and career opportunities of data science in healthcare and biotechnology. So before we begin with today's webinar, let me also take a brief moment to introduce you to the team behind the program. We are a US-based bioinformatics company who is working with multiple academic and commercial collaborators to develop easy-to-use analytical tools, and our mission is to make bioinformatics more accessible. And as a part of the program, students will have access to omics logic training that has been completed by over 24,000 participants from 187 countries in over 300 workshops. And due to this fast growth, our team is working with local and regional coordinators that are helping refine local program logistics and adapting them to the needs of students and researchers around the world. And this training has been completed by participants in 6 different specialization tracks that includes oncology, infectious diseases, precision medicine, neuroscience, data science for biomedical data, and comprehensive training on omics data analysis. Students will also have access to the omics logic resources, but how does it help advance bioinformatics teaching? Omics Logic is a portal for practical and theoretical learning of bioinformatics. It takes a combination of training modules, data analysis tools, curated project data sets, and interactive sessions with mentors to give the student a clear path up the Bloom's taxonomy pyramid. And no matter what the user's initial experience with bioinformatics is, Omics Logic is a useful tool for gaining a baseline knowledge of the theory behind bioinformatics, analysis of large data sets, and introduction to basic coding languages like R and Python, or even beginning a data analysis project. And this also comes with an access to Omics Logic courses, which includes courses on bioinformatics, precision medicine, multi-omics that includes genomics, transcriptomics, metagenomics, epigenomics, data science that includes bioinformatics using R and Python, as well as cheminformatics. and example projects of different fields which you could learn from and replicate for your research work. Users will also be given directions to access the T-Bioinfo platform for bioinformatic processing and analysis of data, and the platform includes demo pipelines as well as data management and analysis cloud infrastructure to run bioinformatic pipelines. Different stages of analysis are performed in different sections on this multi-omics platform. So now, to view the various courses and example projects, let us begin by signing up on the Omics Logic Learn portal. I am sharing the link to sign up on the portal in the chat box. So I would like to request all the participants to visit the link and follow along and sign up on the portal. So for those participants who are creating an account for the first time, you can click on the option that you see here that says create an account. And once you click here, you will be asked to enter your name, email ID, password. Or you can also create an account using any of your social media handles. This could be your Google, Facebook, Apple account, GitHub account, or even Twitter. And for those participants who already have an existing account on the portal, you can simply click on the login now option that you see here and click on sign in, and you'll be able to access your account. So I'll like to pause for a couple of seconds so that the participants can sign up on the portal. And once you have signed up on the portal, please put a yes in the chat box so that I can proceed further and show you the various resources that we have on the portal. All right, so one person has put yes. I'm expecting a couple more of yeses. And if you're having any queries, you can put them in the chat as well, and I'll be happy to guide you on how to sign up. Okay. All right, so we have a couple of yeses. So I'm going to sign in on the portal, log into the portal since I already have an account on the portal. And once you sign in, you will be able to see the various courses and example projects that are there on the portal. So here, if you're looking for a specific course, you can simply enter the keyword that you're interested. For example, if you're interested in machine learning, you can simply enter machine learning, and that will show you all the courses and example projects that makes use of the concept. And now coming to the important part about signing up on the portal. All right, several people have signed up. That is great. And once you sign up on the portal, the important part is that you need to update your account. So a completed profile will have a profile image. The name will be in proper capitalization. You should link your social media handles. As you can see, I have linked my LinkedIn account and my org ID. And your bio should have your education background and research interest. And you can edit all of this in the profile option that you see here, and you'll be able to enter all of the details here and update your account. And now let's explore what are the various tabs that we have. Once you sign up, you have the activity tab. Here, the program mentor and the community manager will be tracking your learning progress on the portal. And under the courses tab, you will be able to see the various courses that you're currently completing. And once you create a research project and upload it on the portal, it will be visible under the projects tab. And once you enroll for any of the programs, for example, the biomedical data science in our program, the program will appear under the programs tab. And finally, after completing the required courses, assignments, and activities, you will be able to receive the certificates under the certificates tab. And with that, I'd like to pause for a few seconds. If the participants are having any queries, you can let me know. Shall I proceed ahead? Is everyone good to go? If so, you can leave a yes in the chat box. All right, so now I'd like to pass on the stage to Dr. Raghavendran Lakshminarayan, who will be explaining about the program curriculum for the program. So over to you, sir.
Thank you very much, Sri Gauri, and thank you everybody for an active participation. So I would like to know about your proficiency in R or in coding in general. I think Sonalika already asked this question, so quickly rate yourself in R or in any programming in general, so that we can understand our participants in much better way. So your 1 or 2 would be absolute newbie, and something like 7 to 9 would be you can borrow codes from existing resources and then modify that for your data and to answer the type of questions that you are going to answer. So quickly type some numbers so that we can get going. So thank you very much, Unmay. And let me start sharing my screen. Great, thank you, Rakesh. Okay, can you see my screen? I need a little confirmation.
Yes, sir. We are
Yes,
able to see.
okay, thank you very much. So let's go over the program curriculum in general, and then I'm going to show you where you can access, wait a second, yeah, where you can access the necessary resources. And then we are going to go over a couple of associated resources to get you understand how we have structured the learning resources and how you can make use of the Learn portal to its full potential. So this is the program page, and yeah, I think you would have gotten a lot of link to this. Let's see. This is where you can access this page. So if you come down, this is structured like twice a week, and we start with giving you a very basic introduction to the program, and also to, for example, loading data in R. So this is going to start or help those people who are starting up their analysis or starting up their introduction to R. So we have given a lot of associated resources, and all of you who would want to get some head start in R, so I would want you to go through these associated resources. Most of them are free because they form the first 2 lessons of many of our courses, and they are free in, for example, setting up R or using R to load data, to just open up a data table in R to understand their statistical distributions. So something like that. And then we are going to move over to how you can produce a variety of different structured data from different omics data analysis. This is going to be very important because as you are going to use many of these structured data in your analysis. So we want to understand how these different where these different data come from, and how to use the pipelines from the big data server to produce this structured data from unstructured data. So all of this would be discussed in the second session. And as we go along, then we are going to introduce you to major types of machine learning methods, where we are going to discuss an overview about, for example, different machine learning tools that are available, like unsupervised machine learning methods, unsupervised machine learning methods, and what you can use, how you can use these methods to answer different types of questions, right? Different data, for example, understanding generally the separation of samples according to subtypes or categories present in the samples can be addressed using unsupervised machine learning methods, right? If we know a little bit about the data, like a prior classification is available about the data or categories are available, we can use supervised machine learning to make the tools or make the model learn from the existing categories and apply that to predict for the new ones. This will be explained and discussed in detail in the upcoming sessions. And then we are going to focus specifically on unsupervised methods and then supervised methods, where we are going to use, for example, a similar data sets to and subject that to different types of these algorithms to compare their results, and comparison with their results among themselves, and comparing their results with existing categories that we can gather from available publications or available information about the data, etc. These will become extremely important because you will get to choose, after learning these, you will get to get the option of choosing which method and which further settings or hyperparameters for each of these methods to be applied to different types of data. For example, a transcriptomics data might require a different setting, and metagenomics data might require a different setting. Like most of the times, we are going to use linear dimensionality reduction methods like PCA to understand sample segregation and to understand sample patterns in the transcriptomics data. But for a complex data like metagenomics data, a simple linear method of combining the features might not work very well. So we have to apply different types of nonlinear data dimensionality reduction methods like TSNE, like MDS and NMDS methods for understanding the patterns in the metagenomics data. So these things will be discussed in detail and will be shown how to perform this analysis in R using R codes. And also you can start, if you want to understand the logic, you can start with performing this analysis in the Turbot Bioinfo server big data platform, so that you have a reference output of how the results should look like. Then you can modify, or you can understand the innate workings with the code. And then the same is what we are going to do with supervised machine learning or classification algorithms, where we are going to start with absolute basics like using binary decision trees, which will ask simple yes or no questions to classify your samples into the types that you are going to make the model learn from. And then to as complex as we will use random forest and LDA, SDA, and support vector machines, etc. In the end, the idea is to understand the limitations and the advantages of these methods separately, so you can pick, or you can actually opt for the perfect method for the perfect type of analysis, right? And that is going to maximize the information content and also minimize the computational complexity of what you're going to work with. So this will be very important. For example, if you want to classify, let's say, tumor samples into their subcategories, right? We can use different tools depending upon the complexity of the data in terms of number of genes for which the categorization is done for. If you have, for example, 20,000 genes, then a machine learning method like support vector machine might not be very accurate in understanding the patterns of the data. So we might have to either subject the method or subject the data into some sort of feature reduction or feature selection methods before applying support vector machines and LDA and etc. So these methods and how to perform this and what are the advantages of doing this and how to effectively interpret the output, most importantly, will be discussed in the sessions that deal specifically with particularly with unsupervised and supervised machine. And then the last two sessions are extremely important because that is going to show you how to combine these different methods that you have been learning so far, right? First, to effectively answer a question, right? And two, for example, to select a specific data and specific project that is going to involve a detailed methodology with selected machine learning analysis to answer a question of your own. So the last session is to provide an introduction to how you can access different publicly available resources to select a specific type of data or a set of data. It doesn't have to be one data. It can be data from a couple of other resources also, and then effectively use that for the question that you want to answer. Maybe my data set can come from repositories like gene expression omnibus, like NCBI gene expression omnibus, which is going to predominantly give you information about the transcriptomics data that several publications actually use it for their analysis. I can collect transcriptomics data for, let's say, a neurodegenerative disease, a set of transcriptomics data that deals with neurodegenerative disease to understand, for example, majority of the genes that are involved, let's say, in the mechanistic aspects of these neurodegenerative diseases. Or I may be interested in, for example, a mass collection of cancer data, which you can get from TCGA, and then use it for further understanding the tumor subcategories or categories of tumor types. And yeah, these kind of discussion on what data to acquire from where and how to use that data to answer a question that you are interested in, and that will be interesting to many other people in the in a project that uses machine learning, will be discussed in the last two sessions, right? Basically. So for today, I am going to, for example, mainly discuss with data processing and visualization. So it all starts with loading up the data and understanding the patterns of the data. And why should we do that? Why should we pre-process the data? If the machine learning methods are so advanced and so intelligent, so smart, then what is the necessary to perform this data processing? So the need for processing this data is actually given or discussed in extreme detail in the BioML course 7 in lesson number 3. So that is what we are going to deal with. Let me share the link once it's loading for me. Yes. So this is where you can load this. This is made free for all of you to explore and understand the necessary or the need to prepare data that is actually reflective of the patterns that is present in the data. So, I mean, you can read through this passage, but this one picture is sufficient to give you the message, right? Irrespective of the type of model that you are building, either it is more complex or more simple, as a good model, or a statistically accurate model, mathematically valid model, it will return garbage result if you are going to give a data that is unprepared, or data, for example, that is filled with technical noise, or data that is completely inconsistent, and data sometimes that has duplicated information, right? So these are not good. So following along, what actually constitutes a good data, or rather, what actually constitutes a bad data, when you should raise a red flag if you see some patterns in the data. So these are all very important points that you should keep in mind. So this will not only affect your machine learning model, but it will affect your downstream analysis in general. So these types of bad characteristics of the data that we don't want in any of our data analysis. So for example, we don't want signal to noise ratio be very low. So that begs the question, then how can we estimate this signal to noise ratio? How can we find out whether my data has a lower signal to noise ratio or a higher signal compared to the noise? So we will discuss this in a short while. And then coming down, whether sometimes my omics data can actually have missing data, or depending upon the type of processing that it has already undergone, it can have imputed data, right? Why we are actually dealing with this? Because for data science applications, we will mainly discuss, or we will mainly deal, or we are going to deal with data that is pre-processed and available at a different data repositories, because our idea is to collect as many data as possible, so that our model can understand the patterns that is available in the data. So in that case, when you are collecting data from several different resources, or collecting data that is produced in mass, there is chance of some of this data can be was not recorded well, or is actually missing. So we need to know about how to handle this missing data, and how much of the percentage is actually acceptable. And when the percentage becomes higher, what should we do about this missing data? So we will discuss that also in the sessions in detail, but we will quickly go through in the next few minutes also. So for example, we might encounter data with batch effects, that is, for example, a consistent difference between sample because of they are measured in two different places, or they are measured by two different persons, etc. And we will definitely, for example, deal with, sometimes we might deal with samples that are mislabeled, because labeling is done by people, and we have to give some sort of error percentage that can arise from labeling from human cases, right? So these are all some of the red flags, or these are all some of the important points that we want to verify whether our data has such bad qualities, and if yes, what are we going to do about that, right? And this is what is addressed in exploratory data analysis, right? And where you can subject your data to a myriad of different plotting methods and visualization tool that is going to help you each and every one of these answer, whether my data has any mislabeling, whether my data is of low quality, whether my data has follows any for example, any required data distribution, right? Many of the statistical methods might require your data to follow a Gaussian distribution. So whether that is actually followed or not. So these are the kind of answers that you will get when you are going to work with data visualization and exploratory data analysis. And most importantly, sometimes, as I mentioned, we might have to collect or gather data from multiple different resources. And also, even within these one single resource, the data might not be in a format that we want it to be. So in that case, how to convert the data into correct format, and what constitutes the format that we require the data to be in, to be used by machine learning analysis, etc. So these also, they're also very important. And by now you would have guessed that using data science methods for biomedical data actually deals with more data pre-processing rather than applying the data science methods. So majority of the work is done before applying many of these more to be discussed machine learning tools on your data. So the data has to be prepared well, the data has to be understood very well before subjecting that to machine learning tools and methods to answer our type of question. So that is very, very important. So this, I'm going to stop with this for this lesson here, but you are extremely welcome to go through this this whole lesson, which is very, very informative, because in the next section, we are going to show you or introduce you to one of the most used dataset, curated datasets from our portal, which deals with breast cancer cell line omics data analysis, where it is where we have 7 different types of molecular profiling done on these breast cancer cell lines. In addition to treatment response data is also available. So you can start as simple as performing visualization options to understand patterns in the data, exploratory data analysis, and as complex as using this data for multi-omics data integration and find out, for example, the cell lines that are going to respond positively to a given treatment, or that cell lines that are not responding to any given treatment, given set of treatments. So this and more about this specific project is actually given in detail in a separate project. If Sri Gauri can paste the cell line PDX cell line project, that will be great. So where we take this data and explain you in detail about what this data is actually telling you, what this paper is actually telling you, and then we use unsupervised and supervised machine learning methods to understand patterns in the data and to help you get a good introduction to how different machine learning methods can be used to answer key questions in using data from publicly available resources. Okay, let's find out this data. PDX cell line. Okay, it's not coming. Okay, thank you, Sri Gauri. Thank you very much for that. Yeah, so you can get that. So for the next part, for the next 5 minutes or 10 minutes I have, so we are going to having established the necessity to perform exploratory data analysis and preparation of data, then we are going to go to another associated resources, which is going to deal with our coding course 2. And we have made this lesson 3, advanced data visualization, free for you to explore again. And yeah, let me go through that lesson, and that is given in this. If I can paste this link here, yeah. So this is given free. So we start with understanding the format of the data, right? So you can view the full table here. So when I spoke about different formats of the data, this is what I actually mentioned. So we want the data to be in proper columns and row format. So you are free to download this data and open it up in Excel and notice generally about this data. This is a curated data set, which is straight away from the cell line project, and that is going to have or fulfill certain that's going to possess some characteristics that we will explore using these data exploratory methods. So what are they? First, we have to load them to understand or to understand the patterns in the data. So the first part is going to deal with how to load this data from your computer into R's environment. So if you are absolute newbie to R, this is where I want you to start. This is already the 3rd lesson in this course. So the first 2 lessons are going to have even basic steps on setting up R or loading the data and then verifying whether all parts of the data is loaded perfectly or not. So I want you all to start there if you are a newbie to R. And then, for example, cleaning the data. You can notice, or you will definitely notice, in this data set, we have some NA values or some incompleteness in this data. So how are we going to deal with that? So if we have this incompleteness, do we here in this specific data, right, we are going to exclude them. And in the session that is going to deal with this specific lesson, then we will discuss about why excluding these NA values is a better choice than doing anything else. So that's what we will do. If you are Google-eyed or keen-eyed, you can see that after performing this incompleteness exclusion, we are actually left with 992 rows. Earlier, we were left with 1000 rows. So we have completely disregarded 8 genes for their information because they have partial information. And then comes a myriad of statistical visualization tool, like we can perform subject this analysis, subject this data to box plot, right? And this is going to show you start like this. That's going to show or tell you about the data distribution in general, right? And what do we need to do for the box plots to look like this, right? We have to transform the data into logarithmic format because the existing format of the data does not follow a Gaussian distribution, which is absolutely necessary for majority of the statistical test and analysis. Okay, Kashish says he is not able to hear me. I hope many of you can hear me very well. And if
Yes,
that is
sir.
the case, Kashish, please check your audio settings. Yeah. So this couple of box plots from your data generally without subjecting it to any sort of pre-processing is going to tell you that the data is not normally distributed or does not follow Gaussian distribution. So for that case, we will simply use a logarithmic transformation of the scale of the data, and then we can make the box plot, which is going to tell us about the data. For example, it's going to tell me that most of the non-malignant samples has a median value or median expression value that is a little bit higher than the Claudine low samples. And we can already see that there is one non-malignant sample which doesn't fit with the other 4. So these are all some of the clues or insights that you can generate after making a box plot like this. And this doesn't stop with box plot, right? You can also make a box plot by grouping the information that is present in different samples, because since these are all biological replicates of sample under one condition, we can group them together. That is going to give us some more information. So I want you all to explore this specific lesson because we have let it free for 24 hours. So this has much necessary or much needed are codes in this lesson. And if you scroll down, it's going to give you insights into what you can learn about scatterplot and how, more importantly, how you can visualize or how you can visualize your data using scatterplot and what you can learn from scatterplot, or options like bar plot, or options like, for example, come down, you can use a histogram, right? And one of the most useful options in this Learn portal is the practice sections, right? In all the coding sections, there are other ways of transforming the data from log transformation. You can normalize the data using quantile normalization, right? So we can discuss that also in the or z-score normalization is another way, but quantile normalization and log transformation will take care of most of the distribution issues, right? And yeah, most useful section in this is going to be practice the code section, where after you have learned to, for example, load, clean, and visualize the data, this is the place that will be explained in more detail in the separate section, because if we go there, then it's going to take a long time. And it is also available in this lesson that we have given free. So feel free to explore and understand how this transformation is actually done and what are the advantages of that. So I want to show you about this practice code section, where it's going to load our console from our server, and you are free to, for example, run codes in this section. So for you to get a clear understanding of what we have actually discussed so far, we have left out little bits and pieces of these codes here, so that you can verify what you have learned in the above sections. For example, if you just run these codes as it is, it's going to throw you an error. It says error running code. So if you read, it says we have actually made some of the syntax is incomplete, and please complete those missing parts based on what you have learned so far. So I'm going to check if there is anything incomplete in the first line. Looks like the first line is actually incomplete. The separator is not actually mentioned. The separator is a tab separated format, right? And most as you would have learned from the above section, and the rest of the section is true. Okay, let's run this again. Let's see. You can clear the output of the console by clicking this and then run it again. And now again, it's giving me some error. So let's check the other ones. Okay, this seems to be fine. And now, okay, this part is incomplete, where I have to check the dimension of the data. The data is not at all mentioned. So let's mention the data and clear it and then run it. then I get the necessary feedback that I have been successful in running the code, and the answer is correct. Sometimes you might encounter, for example, options like the answer is correct. Let's see that, for example, here. So if I do this, if I run this, it's going to tell me error running code. Okay, I just wanted to show you, for example, here, let's see that. Let's see that if this is a test case, and let's see. You say it is also saying error running code. Okay, why is that the case? Okay, I just wanted to show you, but sometimes if there is no problem in your syntax, it's going to show you success in running the code, but the answer is incorrect. That would mean that you don't have any syntax error, but you have some error in which in where you are generating the output. So you want to check your syntaxes and run it again. So that's what I wanted to describe, but looks like I'm not able to do that. But yeah, you can actually keep exploring this. I want to stop here due to time concerns, but this is going to also open up assignment for you, where we have given a complete console free for you to explore, where you can took or pick bits and pieces of the code that you have learned from the previous sections, and then create or complete the assignment, as you can see from here. And for example, if you come down, you will have advanced visualization option, where we are going to introduce you to alternate way of visualizing these tools, which will be extremely useful to, for example, fine-tune the visualization to produce publication quality visualization, right? And we have given practice sections for visualizing this also, right, where you can get the tool to run and create an output here, which you can download or which you can visualize whether it's working perfectly or not. That's what I wanted to show you. And with that, let me hand this over back to Srigauri. And sorry for taking 5 minutes extra. And if you have any questions, I'll be happy to resolve it here. Or if you have more detailed questions, then I will be very happy to answer that during our sessions in the program. Thank you.
All right, thank you so much, sir. So there is a query in the chat, like how to complete the program. Said Alam, first you need to enroll for the program. We will be discussing about the program registrations in a little while. And meanwhile, we are waiting. Let me just share my screen. And is my screen visible?
Yes, Srigauri, it is.
All right, so for the next part, I'd like to invite Dr. Jeet Sarkar. He is a physician scientist with a keen interest in data analytics and precision medicine. He's passionate about finding meaning out of biomedical data and leveraging them for better clinical outcomes. And his current work generally involves offering meaningful and translational guidance to biological and healthcare organizations. Currently working as a senior bioinformatics scientist, I'm sure we will be able to learn a lot about the field and the opportunities that the field has to offer. And with that, now I'd like to pass on the stage to Dr. Jeet Sarkar to start with today's expert talk. So over to you, sir.
Thanks. So can you hear me?
Yes, sir.
Okay. So let me share my screen. I guess you people can see my screen.
Yes, sir. Yes, sir, it's visible.
Okay.
Yes, sir, it's visible.
Okay. So hi. Thanks for the opportunity to speak at this webinar. So I know it's a very introductory webinar. I will talk mainly just to give a very basic introduction of health informatics. So as already mentioned, I come from a very sort of a maybe a different background. So I have done my basic clinical degree MBBS almost 7 years back. My interest was always on data and data analytics. So after MBBS, I slowly shifted towards doing my PhD in bioinformatics and data science. So currently I work as a senior scientist, and I handle multi-omics data, which ranges from transcriptomics, proteomics, metabolomics, and I also work with EMR data, health record data, and building predictive models out of those data, and also to provide solutions, customer solutions as per their need. So this course is going to cover more or less. I will limit myself to the genre of health informatics. So it's more of a healthcare data science. So I won't speak at length on transcriptomics or other multi-omics, biotech related omics things. And today is the introduction. So just let me start it. So I have just prepared a few slides for today's talk. I have briefly divided them into 3 sections: experiences, my experiences, data science in healthcare, where it stands today, and some of the challenges and opportunities which are still now and which will be coming more in the coming nearby future. So starting with this has been my journey. So if you see, it's more of a transition from healthcare delivery to healthcare research. So as I have told, I have done my graduation from in MBBS, and then afterwards I did my clinical residency. It's more of a physician kind of role where I used to treat patients and attend to patients like that. And then I slowly shifted to clinical research. The research question was majorly clinical practice driven, and I had my major focus on type 2 diabetes almost 6 years back. Now from clinical research, I slowly shifted towards bioinformatics and then health informatics. So why am I giving this particular slide? And so the idea is to tell any learner from any age, in any stage of his or her career or education, that you always have the option to switch and shift from domain to other domain. And today, given the amount of resources you can access to, open source resources like Pine Biotech, so it's very easy, given you have the motivation and the right choice of your goal, you can also do such short of switches. So again, my graduation, my clinical residency and clinical research, this was majorly for academia. So I had spent almost 6 years, you can tell, in academia. Research, I spent the coming 5 years. There would be overlap between academia and research. And only for the last 2 years, I have been into the industry. Now, again, why do I mention this also? Because nowadays things are coming, surfacing out that there is a big gap in academia and research and industry. And maybe there are certain skill sets which academia doesn't empower with us, which we need for the industry. But still, there is plenty much opportunity to upskill yourself, to learn new things. And this might not be a very abrupt journey for some, might be very abrupt for some. And there's always scope to transform yourself from academia to research to industry. So there are options. So I would just tell everybody to explore more and more. And things are not that much of difficult and critical as it might look. You just need to be consistent and things will surely work out. So again, the next thing is, what did I learn from academia? So is it nothing that academia didn't teach me, or there are some things? So yes, there are some things. So in academia is actually the place where you go to know the basics of biology. So in my case, biology. So the basic thing, so what is a cell, what is a tissue, what is an organism, what is a gene, what is a protein, what is transcription, translation, what is transcription regulation. So these very basic things, this nobody is going to teach you. Nobody is going to spend the effort to teach you. These basic building blocks is what academia can only teach you. So from my perspective, I got into the basics of biology, basic of medicine, then health and disease. What is a disease? How do we define disease? And for my particular specific background, clinical approach to medicine and public health approach to medicine. So this is more of a professional degree. So where I just learned what to do and what not to do. I had a very limited scope of innovation or innovating or learning new things or telling or discovering new things. Something which I could achieve in my research during my PhD. So from this academic background, I tried to zoom in one or two questions, one or two pertinent problems, and I was taught the art of quantifying things in my research. So now I learned. So majorly I focused on quantitative methods. So how do we quantify medicine? How do we quantify a problem? How do we quantify, suppose, RNA expression in normal cell versus RNA expression in a disease tissue? So this art of quantification that involves pre-processing, processing, and downstream analysis. So this quantitative approach to medicine is what research taught me. Now that was also something incomplete until I came to industry, where I could bridge the gap between academia and research and make it into a product that will be serving purpose of multiple people. So this journey from academia to research and industry, this has been quite I would tell, diverse journey, quite a exciting journey. And there are things which you get to learn only in that duration of your life, in that duration of your career, and you should try to make the most from wherever and whenever you are right now. So now coming to the next big section is data science in healthcare and biotech. So where we are right now. So this is a survey market analysis done by McKinsey and Company, and they had tried to identify the amount of venture capital which has been invested in AI companies who work in healthcare over the last maybe 5 to 7 years. So, and you see there are three large US, Europe, and Asia, and this is the number. This is the venture capital amount invested, and you can see the growth. The growth is actually tremendous. So between these 4 years, that has been a growth of 5x, 22x for Europe, and 28x for Asia. So the growth is going to be massive in healthcare domain. Healthcare data is a big source of data. It requires tremendous amount of data storage and data computing facility. And with the modern day computers, all the GPU chips and all those things, cloud computing, the healthcare data handling capacity has increased. But what we are lacking is a proper human resource who will be well equipped to handle this healthcare data, and that's something which is still pending, and that will come in the coming maybe 1 decade. And these would be the major things of healthcare AI solutions. We can do chronic care management. So in any chronic care, it's diabetes, hypertension, heart disease, or atherosclerosis. In any chronic care management, data and data-driven decision is what is going to be the future of healthcare. Self-care, prevention, wellness. So self-care as we entered in, as the demographic shift occurs, so we will be having much more geriatric population in the coming 1 or 2 decades. And so geriatric population who will be requiring more prevention, more self-care, more home-based healthcare. So that's a very important area for healthcare AI. Triage and diagnosis. Again, as the disease burden increases, we have to stratify patients into high risk, moderate risk, low risk, and we have to design the healthcare in such a fashion that high risk patients get more attention compared to low risk or moderate risk. So this triage and diagnosis is also something very hot right now. Diagnostic, so COVID, the entire COVID era and all these things have shown us that diagnostic, these RT-PCR kits, these are a very such a domain of AI where healthcare is going to succeed. Clinical support. So as doctor and patient ratio becomes more and more disparate, as the patient burden increases over a particular physician, clinical decision support tools will surely come into place. And care delivery is also something where point of care, home-based care, these are very in very primitive stage right now, but that is also where something where AI is going to put some marks. So this is the broad spaces where healthcare is going to transform. And if I just tell you from the company name, so this can be the, I guess, top 50 companies with the headquarters and total amount of million raised. So you can see that almost it's $8490 million, which is the top 50 funding reported, and the top 10 has around 58% of this entire funding which has been raised. So it's a big investment from the venture VC funding, and opportunities and solutions will be massively increasing. So we also need to prepare ourselves with the right kind of knowledge and expertise. So now, how data science can transform healthcare? So just going to a bit of more granularity right now. So the first thing is patient care. So healthcare, the central character in healthcare is a patient. So data science would be successful if it can transform healthcare by giving better and quality patient care. So what can be the key areas of delivering good patient care? So there can be multiple of things in this particular area. So managing appointments and clinical visits. So there's something called waiting time, and this is a very important marker of a truly skilled hospital facility, where the waiting time is minimal, or the less the waiting time, the better is the facility, and the better the delivery service, the better the footfall. So managing appointments and clinical visit. Precise diagnostics. So there is something called precision medicine, which is coming up in the last 5 to 6 years. And now people are telling that no one disease is actually one disease. It's a cluster of multiple diseases. So arriving at precise diagnostic using transcriptomics data, proteomic biomarkers, arriving at precise diagnostic will help in delivering precise treatment and better recovery. Early disease prevention. Prevention is going to be the next big thing. So right now we were focusing mostly on cure. So disease occurs, we have to cure it. But even at a prevention stage, things are now coming up that people are talking about prevention. That if you can have some biomarkers, which biomarker will tell you that this person is going to have a high risk of type 2 diabetes in 10 years, then you will be following a lifestyle modification at a much earlier stage. So right now, what happens? Somebody is diagnosed with type 2 diabetes, and the physician tells the person to modify the lifestyle, do some diet restriction and exercise. But reports and studies have reported that this may not be that much of helpful, because the pathology and the damage has already been done. So people are telling that the damage occurs at least 1 decade before the disease actually manifests or shows up. So prevention is important, so we can prevent it at a much earlier stage, and maybe this lifestyle modification may be implemented 1 decade back. That will, of course, increase the efficiency and reduce the mortality, morbidity. There are certain metrics to calculate a good lifestyle and all those things. So prevention is a very important thing which is coming up. Patient triage. So as I told, that stratification, classifying patients into high risk, low risk, moderate risk, and thereby providing them care is what is called patient triage. And imaging and diagnostics. So as you know, much of the imaging right now, suppose say CT scan, USG, MRI, they already have some computationally calculating thing which already diagnose. So ECG already comes with some automated diagnostics, automated reports. Now, medical imaging is a big booming field. And in the era of COVID, the thing was that to know that this patient is suffering from COVID, RT-PCR was taking, suppose, close to 2 to 3 days. So for 3 days was a very critical time for a particular patient. In that case, in that scenario, people were talking about image-based diagnostics, where based on an X-ray image, if you can identify whether it's a COVID case or a non-COVID pneumonia, and that to do that, we need lots of deep learning algorithms and deep learning algorithms with lots of image data with a proper compute facility. So this is also something which also is coming up. The next big thing is business and management. So this has nothing to do with the patient care, but again has much to do with the patient care also. So what are the big things, if I can just tell in 1, 2, 3, 4, 5? So first is process automation. So suppose robotics and these things will also fall into this category. So suppose there is one thing called diagnostic lab turnaround time. So when a sample is being collected from one particular patient, now that sample has to reach to the lab and the test needs to be done. Now the smaller this particular, the minimum this particular time, the more correct the diagnostic result. And there are already automated things. So it is a sort of tubular channels in the hospital. So when you collect the blood, you just put it in a, you just open a hole in the sort of a door in the window in your wall, and using suction technology, it will automatically take the particular vial into the diagnostic lab, which is located in the 10th floor of the building. So this is a very used example of process automation, and we can use similar automatic robotic based services for healthcare administration. Claims administration. So claims and medical insurance is a big thing right now. In the US, in the Europe, it's already a big thing, and in India, it's already coming up. So claims records are again massive healthcare records. So extracting relevant information from claims history, and then calculating the premium amount, healthcare premium amount, and all those things is a big thing. And claims record administration is a big invites a lot of talent, and they are already trying to automate the entire process to increase the claim settlement or claim premium calculation time. So suppose you come with a claim history of 100 pages. So instead of going through it manually, if there was a system which could automatically scan it, extract all the important relevant terms, and then calculate a score of your risk, and then calculate a premium amount, that would be increasing the claim adjudication and all those things. Customer churn, chatbots, as we are going to more and more mobile based services, so chatbots and business insights, these are also some important questions in business process management. Lastly, we come to pharmaceuticals. So pharmaceuticals also includes vaccines as well as drugs in my case. And drug discovery, as you already know, drug target discovery that involves finding out particular gene or genes which are important in the disease state compared to the normal state, then finding out drug molecules and whether the drug molecule and the drug target are properly aligned, or docking is using docking techniques. So those things are studied here. Planning logistics and improving clinical trials. So clinical trials is something, it's a big sort of a revenue burner in the pharmaceutical industry. So much of the investment goes into the designing clinical trials and implementing clinical trials. And this is something also, clinical trial data, ability to analyze clinical trial data is also something which is which needs a bit of AI and data science right now. So now the challenges. So now, as you know, the more the problems, the diverse the data field, the more the challenges. And the first challenge, which is a very big thing in data quality, is and data infrastructure. So data quality is something which is very critical in health informatics. So we lack quality data aggregation as an integral part of healthcare delivery. So suppose people capture healthcare data as a part of healthcare service. So they are rendering some service, and in that course, they capture healthcare data. So healthcare data capture is more of a secondary purpose. And that what makes the quality questionable and doubtful in some cases. So that's a big challenge, because models, any AI model, any ML model, you can't build a good AI or ML model with a bad data. So the assumption is you are having a very good quality data, and then only you can build a proper AI or ML model. And the next thing is the lack of fairness for healthcare datasets. So what is fairness? Fair principle is something which applies to the biological domain. So data should be findable, accessible, interoperable, and reusable. So, and data should be, so one hospital at maybe in India is capturing clinical data. One hospital in Singapore is capturing some clinical data, one in the London and one in the New Jersey. So now these four hospitals would be having different standards, different structures of the clinical data. But if you wish to merge these four data sets, then you have to reach to a standard procedure. And this is a big challenge. So people will be capturing data in different pattern and fashions. And you have to make those data, you have to curate the data, and you have to make it standardized and harmonized. And a lot of time goes into this particular data verification for healthcare data. There are solutions. So the first solution is building more clinical registries. So clinical registries are actually pre-planned data records. So it's not that you are providing healthcare and you are capturing data as a secondary thing. Not that you capture data. That's your primary goal. And in the course of data capture, you also provide healthcare, but it's a very costly thing to do, implement, and maintain. And the next thing is preparing a proper ontology for fair and datasets, so that what the hospital in Delhi, those patients suffering from type 2 diabetes with diabetic retinopathy, you can also get a similar set of patients with a similar set of diagnosis from other locations also. So given you are properly, you are doing a standardization of this disease column. So you can map multiple diseases, you can club diseases, and you can do a large scale combined analysis. The next challenge is actually compliance and governance, because data, healthcare data is very restricted and very sensitive. So, and there are very complex regulatory guidelines for healthcare data storage, collection, and utilization, like HIPAA, GDPR, and CPGR. So there are lots of techniques which people have suggested, but it's not a very straight-cut solution. So there's something called federated learning. So in federated learning, so generally when we build a model, we take data from multiple sources, we store them in a central repo, and we run the model there. We build the model there, we run the model there. But in case of federated learning, we don't do that. The data resides into the local server. The model is built in the local server, and the model gets deployed and implemented there also. There only. But the model parameters will be only the model parameters will be stored into the central server. So no data is stored centrally. All data resides locally in the particular hospital in their servers. Only the model parameters are stored centrally. And this is, so there is a sort of a feedback mechanism. So as more data increases, the model parameters change. They update the central repo model parameters, which in turn also updates the parameters of a different hospital. So this is how the thing works. This is something called federated learning. But again, it's a very tricky thing to implement. There are lots of expertise is needed for that thing, but there is a feeling in the industry that things are going in that direction, because you can't aggregate and store diverse healthcare data into a central repo given the data sensitivity. Lastly, and which is where Pine Biotech and this program comes into place, is data science skills. So suppose you have data quality, you have data infrastructure, you have all these data collected and created. Now what you do? So there is a tremendous lack of health data literacy among healthcare workers. So any physician, any nurse, anybody, they have a tremendous lack of health data literacy. And even skilled data analysts who also understand the complexity of healthcare domain, that's also lacking. So those who come from healthcare domain have no clue about data science and health informatics. So that's where this sort of course is going to help. And believe me, again, given the huge going to be explode in the genre of data science and health informatics. This is some skill which is going to be required in this particular healthcare industry. And this is where the knowledge and skill of various data sources, various healthcare data sources and data types, and how to clean them, how to standardize them, how to curate them, how to conceive important models, and how to build those models, how to test those models, and how to deploy those models. This entire skill is going to be a very rare skill in the coming future. So next, I move to the challenges and opportunities. So challenges wise, I have already mentioned it in a iterative fashion. Again, I will just mention it. So one thing is the problem in data acquisition. So you can't get data so easily because, and suppose for some cases where you have to do some real-time prediction. Suppose you have a person who is wearing a Fitbit, a wearable, from where you are capturing the blood pressure. Now the blood pressure is dropping down gradually, and it's dropping down very steeply, and it tells you that the person is going to have a fall, because it's going down consistently. Now from there, you need to give a particular notification to that patient or to the relevant care providers that this patient is going to have a fall. So for that, you need some real-time data streaming and real-time data prediction, model prediction, and notification. So this entire thing, this involves lots of expertise. You need database administrations, you need model deployments, you need data scientists. There are lots of things for a very simple problem. But this is something which is a very challenging thing, capturing and storing and predicting from real-time or near real-time data, which is very, very important in healthcare informatics. Next, as I already told, harmonizing data. So you have to standardize disease, drugs, symptom, procedures across different data sources using proper ontology mapping. So you need to know that how do I standardize disease? How do I do this for drug? From where do I find the information that which drug treats which disease? Which drug should not be given in which disease? So what are all possible relationships between drug and disease? So that is a very big area, that there is something called medical terminology, and there are multiple available ontologies. And so that's also which is a very important resource to be learned for health informatics. Next comes model building. Now, model building, I guess we will be talking more on model building. So it has two very vital steps. One is feature engineering, one is model building. So feature engineering means you process some biomedical data from different sources. It can be omics source, it can be EMRs, vital wearable parameters, images, scans and images, and you convert them to clinically meaningful features called feature engineering. So you just translate or transform the data into some structured features. So this feature engineering will depend on the data type. If you are using image data, then you will be extracting pixels and pixel features. If it's a colored image, you will extract RGB3 different channel features. It's a black and white image, you will extract only 0 to 1 to 255 black and white pixel feature. If it's clinical notes, you will be building word embeddings. If it's a tabular data, then it's already a tabular data. You need to normalize it. So this feature engineering is something very important in healthcare data. Next comes, so once you derive the features, you can use them into the models. Where you can make supervised models, unsupervised models, neural networks, graph networks. Another thing is, after you build the model for health informatics, you also need to provide something called interpretability. Now, healthcare is a such domain where you need to provide the interpretation, which is now being called as interpretable AI. So unless the care provider knows that this is the cause for which, this patient was having a consistent drop in the blood pressure for the last 2 minutes, and that's why the model has told me that he is going to have a fall in the next 5 minutes. So this interpretation has to be there in the context of healthcare informatics, or it won't be that much of deployable or translatable in the healthcare domain. So these two things are also big challenges in the healthcare informatics. Now, what are the industry roles? Now, we all of you know about the bioinformatician. So who work with omics data, transcriptomics, proteomics, and yes, and this particular expertise is needed in this field also, majorly in oncology, where the idea is to subtype and precise subtyping of a particular breast cancer or colorectal cancer or any liver cancer, and that will help you to cater more precise therapy, more precise drug regime for particular subtypes. So omics data is also needed in this particular industry, that expertise. Then something called clinical informatician. Now, the role of this clinical informatician is to work with all possible clinical data. It can be clinical notes where the person will be using NLP-based techniques. It can be image data where deep learning images and all those things transfer learning would be used. Medical terminologist. I have already told about this, that because there are lots of disparate data sources and people are using different terms, so we need to do a proper mapping. And this is what is called medical terminology, is the job profile for that. So we harmonize and we map it so that we can combine data from disparate sources and get a central source for generating insights. biomedical data curation. So publicly available is lots of data. So publicly available data, proprietary biomedical data, you have to curate and you have to structure it. That's a big there's a big demand of this particular job role in the industry. Biomedical data scientist. So feature engineering and building AI models for clinical decision support is something which falls under the JD of this particular role, data scientist. And lastly, something called solutions architect, who actually connect all the technical details of a problem, a business problem in healthcare domain. So suppose we want to, a company wants to build a fall detection algorithm, and the architect will tell the company that you need these things in this place. You need to have a remote monitoring device. You need to connect it to a database, and the database will live stream the data. These will be the models which will be running in maybe every minute or every 2 minutes, and there will be notification on how that had to be sent. The entire end-to-end thing is the what falls under the domain of the solutions architect. And there are many more industry roles in the context of, in the case of health informatics. So I guess I'll just end today's discussion here, and I guess I just took 4 minutes extra. And any questions, I'm open to the questions right now.
Thank you so much, sir, for the wonderful presentation. And we do have a few queries in the chat. And one is from Saksham Bhatia. He's asking, why is there an intersection between process automation and business management?
Just let me see the question.
Sure, sir.
Where is the?
I'm pasting it in the chat once more so that you can.
I am. Where is the interaction? Okay, so process. So there was something called business management. Okay, so I guess your question is why have I clubbed these two things, automation and business management? So actually, process automation, this largely falls under the domain of hospital administration. So business management and automating processes sort of a part. So process automation helps in scalability, and scalability helps in arriving at better business outcomes. So that's why I have just clubbed these two things together. Yes, you are sure, you are right. We can also detach both of these things. That maybe would be better. Sure. Thanks for the suggestion.
Right, sir. And there is
HIPAA.
one more.
What are the HIPAA and CPPR is what Saksham is. So HIPAA is a guideline. It's a more of a US guideline, and CPPR is a European Union based guideline. So there are particular guidelines for data sharing. So if you are sharing data, if you are storing data, so where do you store the data? Is it secure enough to prevent data leakage and all those things? So those falls under the so suppose AWS servers is what people majorly use to store the data, and those are also HIPAA compliant. And so your storage bucket, if whether it's secure enough, so that data doesn't get leaked, is what those things. So it's more of a certification. Okay, so it's more of a that you are certified by HIPAA, by CPPR, and all those things.
All right, sir. And I guess that was the last query. And thank you so much, sir, for joining today's webinar. And thank you for taking the time out of your hectic schedule to join us and share your knowledge with us. And with that, now we would like to move on to the next part of today's webinar. For that, I'd like to invite my colleague Sonalika to explain the program registration and cost. So over to you, Sonalika.
Thank you so much, Srigari. I hope my screen is visible.
Yes, it is visible.
All right. So we had a lot of queries in the chat box regarding the registration part. So finally, we are here to discuss how you can register yourself for the program Introduction to Bioinformatics in R. I am currently on this landing page that I'd like to share in the chat. Or Jessie, can you just share that? All right. So on this landing page, if you scroll down, just a second, something has happened to my screen. It's freezing up. All right. So on this landing page, if you scroll down, you will first of all find the whole schedule of the program. All the session details, what topics are we going to cover for each one of these sessions. And each session has some associated resources with it, which includes the courseworks and lessons and practice sessions as well on the Omics Logic Learn portal. And each session comes up also with some collab notebooks for you to practice with. So we have just mentioned some of the resources that you would have to refer to as a part of each and every session. So one is this page that you can refer to for the schedule of the program. And also I'm going to take you to the program page shortly to show where you can find all the
Sonalika, it looks like your screen got.
yes, just a second. Let me reshare my screen. Okay, can you see it now?
Yes.
All right, now it's working. Thank you so much. So on this program page, if you scroll down, you can find all the details of the program, first of all. All right. And along with the program details, you also have different payment links that maybe you can pay to, first of all, check out for the specific number of days that you would like to enroll in the program for. It could be either 45 days or 60 days or 90 days. And you have two options to either pay in USD if you are from a US country. And if you are from India, you can pay it in INR as well. And you have the option to pay later as well. You simply need to click on the checkout button for the number of days that you would like to enroll. It could be USD or INR, and then pick the option and proceed ahead. And if it is done collectively, then you are going to get some discount, I believe, that would help you with a scholarship to get started with the program. This was one thing. And the other thing that I also wanted to mention here was about the program page that you can visit to and register yourself for the specific program. Now, on the program page of Biomedical Data Science in R, you'll also find the session schedule, first of all. And this is the program page that the users have to refer to watch the recordings of the sessions and also get along with each and every associated resources or the courseworks that are mentioned for each and every session. Thank you, Josie, for sharing the program page in the chat box. Now, if users feel easy to follow along the landing page to register themselves, they can. Otherwise, you can also register yourself on the program page. Again, you have the whole session schedule mentioned here, and you can pick up the number of days for which you would like to enroll yourself. Now, let's talk about why do we have these different number of days that you can pick and enroll yourself for. So in the 45 days of the registration plan, what happens is you get the access to all the sessions and also the recordings and the resources, but the duration is limited to 45 days. And those who want to work on a project, and before working on a project, they want to prepare their project proposal with the help of the mentor. They have some ideas that they would like to work on, and they want to work on a mini sort of project, I'll call it up, where they can have a research proposal in their hand, and also they can present their research work in a poster presentation competition, let's say, through this mini sort of project, then they can enroll for 60 days. And if they want to work on a full-fledged project and maybe have a publication towards the end of their research work, then they can enroll for 90 days. As it is evident, obviously, if you want to work on a full-fledged project, validate your results, it would take some time. So the resources remain the same for all of these different types of days, but it's just the accessibility to these resources. It would be either 45 days, 60 days, or 90 days based on the number of days that you pick for to register yourself for the program. So that was about the registration part. You just need to click on the Buy Now button, and on top, you can change the currency based on the country you belong to. You can change the currency like this, and it would be of help. Now, we also have some scholarship opportunities for students and also PhD scholars who are seeking scholarship to join the program. You can reach out to the marketing manager, Ms. Parsh Thar, on marketing@omicslogic.com, and she will help you with a scholarship form that you can fill it out, and then she'll let you know what scholarship you can pick to register yourself for the program. Thank you, Sri Gauri, for sharing the details in the chat box. If there are any questions, you can please ask. And we also had some questions regarding certification. So yes, after the completion of the program, you will be provided with a certificate. And those who will work on a research project after completing their 90 days of duration, they'll also get a research fellowship program certificate where the title of the research project would be mentioned, followed along a letter of recommendation if required for their further studies or any project work ahead. Are there any questions? If yes, you can please put in the chat box. The team is here. We can help you out. All right, so if we have no more questions, I think we are good to end today's meet. And we have shared the details with you. You can reach out to us for any scholarship related queries, or if you want to enroll for these different number of days, but are not sure how to proceed ahead, you can reach out to us and we'll be glad to assist you. Thank you so much, everyone, for joining. Have a nice day.
Have a nice day, everyone. Bye.